Let's open up our science journal and go to a blank page, brand new. 3 questions that I would like you to write down and leave a blank spot in between each one. All right, question number 1, what's a tide? Question 2, why do they happen? Question 3, what are the different types? Hopefully by the end of today, you'll be able to answer all 3 of those, no problem. Let's get started. What causes tides? Well, there's some things that don't cause tides. It's not wind. Those cause waves. It's not earthquakes. Those cause tsunamis. Plate tectonics would be kind of earthquakes, tsunamis. Those are not tides, okay? Those do cause water to move. They do displace quite a bit of water, but they are not tides. What causes tides is gravity between the sun and the moon and planet Earth, okay? So the sun is pulling on us with gravity, the moon is pulling on us with gravity. That is going to cause tides. Throughout the centuries, people didn't realize that the sun and the moon were pulling on us with gravity. They had to come up with a reason that the ocean got higher and then lower and then higher again, and it repeated over and over again. They were trying to figure out what was going on. Some people believed that the earth was a living thing, a living being, and it was breathing. Maybe the ocean was the blood of earth and it was pumping, similar to what they saw in humans or animals with the heart pumping blood, causing blood to spurt. In early Islam, people thought that it was when the angel of the sea would put his foot into the sea, just like when you get into a bathtub, you displace water and it goes up. Some cultures that also viewed the tides as a sign that their god was angry, and so there were actually sacrifices made during high tides to try to appease their god. Then Isaac Newton, that's a fun name, Newton. Isaac Newton came up with his law of universal gravity. And with that, we realized that the moon and the sun were pulling on planet Earth with that gravity, and that could explain why the tides happen. Especially because people for a long time realized that certain tides happen during certain phases of the moon. And if we figure out why phases of the moon happen, we can correlate that with when high tide is, when low tide is. Everything started to make more sense. Thanks, Newton. So what is a tide? Well, in this class, it is not laundry detergent. It is something completely different. We just figured out that gravity is wanting to bring things closer together. So the moon and the sun are pulling on Earth through gravity, and it wants to bring everything that's on Earth, including Earth itself, closer to itself. Well, water is not solid, it's not rigid, which means it can move, it can flow because it's a fluid. So water is going to bulge up towards wherever that gravity is pulling it from. Earth is then going to rotate in and out of that bulge. The bulge actually stays there because the sun and the moon don't go away. There's always gravity from them. So the bulge is always going to be there. It's just the Earth rotates into that bulge and then rotates back out. We're going to start the Earth spinning and the moon orbiting. All right, we're going to include the sun. So the sun is off in this direction. And you will see that the bulge doesn't go away. It actually stays and is going to be pulled towards the moon and towards the sun. And the bulge is going to stay pointed towards the moon. And the Earth actually rotates into the bulge and out of the bulge. That's what causes the tides to go up and down. It's not like the moon stops pulling on the water all of a sudden, and so it goes down. What happens is the Earth rotates into that bulge, high tide, then out of the bulge. You'll notice too, when the moon and the sun are lined up, the bulge is much higher than it is if the moon was up here. So let's let this run a little bit more. And as the moon is not in line with the sun, the bulge will still be there. However, it's not nearly as pronounced. It's not nearly as large as when it was lined up with the sun. So this is a high tide if you were right here on Earth, but it's not nearly as high as if the moon was over here. And what do we call the phase of the moon when it's in between the sun and the earth? That's a new moon. Let's let this run just a little bit more so we can get back to a full moon where it's the sun and the earth. The moon is on the other side. And you'll notice the bulge actually increases, and it's now the same size as if the moon was over here. So during a full moon or a new moon, the high tides are very high, the low tides are very low. And we'll get in just a second to the reason that there's a bulge on both sides of the earth, whether the moon is over here or over here. One thing that you need to know about gravity is that it depends on two things. One, how big an object is, how much mass it's got. Two, how far away things are. So the sun has more mass than the moon, but the moon has a greater impact on tides because it is so much closer. And distance has a bigger impact on gravity than the mass of the objects. Distance is the most important thing when we talk about gravity. With that said, the farther away something is, the less you feel of its gravitational pull. Let me repeat that. The farther away something is, the less you feel of its gravitational pull. And I changed my shirt to explain this to you. What we have is a bulge of water that is close to the moon. Because it's close, it's going to feel gravity stronger than the Earth itself will. And then the water over here is far away, and that's going to feel the least amount of gravity from the moon. So if we split this into three little sections, the water here, Earth, and the water here, you can see that this water being the closest to the moon feels the strongest gravity and will be pulled this way the most. Then the Earth feels the second most gravity because you measure from the center of the Earth, and that will be pulled the second most. And this water here, because it's so much farther away than the center of the Earth and the water here, it's so much farther away that it feels such little gravity, it almost kind of just gets stuck there and it hangs there in space. And the Earth is almost pulled out of this water here. So the distance to the moon is going to affect this being pulled the most, the Earth the second most, this the third most. And that's going to result in there being 1, 2 bulges at all times.
Because gravity gets weaker at longer distances, the moon pulls the near side ocean more than the Earth, and the Earth more than the far side ocean. When the Earth spins relative to the moon, the water sloshes, and we call it the tides.
It's weird to think about, but here's a video that might help.
The moon. It has gravity, but much less than the Earth because it's less massive. It's 380,000 kilometers away, so the gravitational force it has on you is pretty small. And you're pretty small compared to that distance, just a couple of meters long from head to feet. But the Earth is big. It's nearly 13,000 kilometers across. That means the side of the Earth facing the moon is about 13,000 kilometers closer to the moon than the other side of the Earth. This is a pretty big distance, enough for tides to become important. The side of the Earth facing the moon is pulled harder by the moon than the other side of the Earth, so the Earth stretches. It becomes ever so slightly football-shaped, like a sphere with 2 bulges, one pointing toward the moon and one pointing away. This is probably the weirdest thing about tidal forces. You might expect only one bulge on the side of the Earth facing the moon. But remember, we measure gravity from the centers of objects. The side of the Earth facing the moon feels a stronger pull toward the moon than the Earth's center, so it's pulled away from the center. But the side facing away from the moon feels a weaker force toward the moon than the Earth's center. This means the center of the Earth is being pulled away from the far side. This is exactly the same as if the far side is being pulled away from the center, and that's why you get 2 bulges on opposite sides of the Earth. The tidal force is therefore strongest on the sides of the Earth facing toward and away from the moon, and weakest halfway in between them on each side.
We have different types of tides. The first one is when the sun, the Earth, and the moon are all lined up. We call these spring tides. The gravity of the sun and the moon kind of add together, and we get higher high tides, lower low tides. These bulges are just a little bit larger, and so when the Earth rotates into that bulge, the high tide for wherever that is on planet Earth is going to be higher, and if you are over here with a low tide, it's going to be a little bit lower. What I want you to do is jot this little sketch down in your science journal so that you have a visual representation that a spring tide is when the sun, the moon, and the Earth are all lined up, whether the moon is in between, or the moon is on the other side of Earth during a new moon or a full moon, either one is going to result in a spring tide. The other way to align the sun, moon, and Earth is if the moon is at a right angle to the sun. If it is perpendicular, either at a third quarter or a first quarter phase of the moon, these bulges are going to kind of cancel each other out. We call this a neap tide, N-E-A-P. Neap is a weird word that you only are ever going to hear when we talk about tides. And we have these bulges canceling each other out. So the high tide is still there, but it's not nearly as high as a spring tide. The high tides are not as high, and the low tides are not as low. You can see that the bulge is still bigger going towards the moon, and the reason is that the moon is so much closer than the sun. So here's a high tide, here's a low tide during neap tides. You should have both of these sketched in your science journal by now. Spring tide has the sun, the moon, and the earth all in line, either during a new moon phase or during a full moon phase. A neap tide is when you have a third quarter phase or a first quarter phase. You can tell that the bulges are much larger during a spring tide than they are during a neap tide, which means the high tides are going to be higher, low tides are going to be lower than they are during a neap tide. Tides happen twice a day. And the reason is that you can see that there were two bulges. So anywhere on Earth is going to rotate into that bulge twice per day because there's two of them. They happen about 12 hours and 25 minutes apart. Why not exactly 12 hours? Has to do with the exact same reason that we have different types of days. Because as the Earth is spinning, it's also orbiting. So that bulge is going to shift. Because Earth is traveling in its orbit, the sun is going to be in a little bit different spot, which means it doesn't take a full 360-degree rotation to get back to that high tide. Turns out that's about 12 hours, 25 minutes apart. Not only do tides happen twice per day, about 12 hours and 25 minutes apart, because Earth is going to rotate into those two bulges, which are caused by the gravity between the sun, Earth, and moon. The tides themselves are going to look differently. They're going to be faster or slower. They're going to be higher or lower, depending on a lot of things. Things like the structure of the ground under the ocean, or the landforms of the bay that you're standing on. They also are going to be affected by the distance of the moon. If you remember, the moon travels in an ellipse. Sometimes it's closer, sometimes it's farther away. If it's closer, more gravity, higher tides. If it's farther away, less gravity, less high tide.
The Earth completes a full rotation once per day, and hence the moon passes overhead pretty much once daily. So then why are there two high and low tides every day? Simple. The moon's gravitational attraction is stronger the closer you are to it. So the close side of the Earth gets pulled away from the middle, which in turn gets pulled away from the far side. As the Earth rotates, these so-called tidal forces cause water on the surface to slosh around as high tides twice per day, once when the moon is directly over your head, and once when it's directly below your feet. So why is gravity weaker at a greater distance? Well, imagine you're spraying a stream of water at a sheep. If the sheep is more distant, less of the water hits it than when it's close, so there's less force pushing it away. Gravity behaves the same way, except it's attractive. And there are tidal forces from the sun as well. They're weaker than the lunar ones, but when the sun and moon line up, the tides pack an extra punch. It's not just water that sloshes either. Tidal forces cause the Earth's crust to bulge as well. We just don't notice because we get lifted along with it. And tidal forces from the Earth cause the moon to bulge too. All this bulging and sloshing dissipates some of the Earth's rotational energy, causing it to gradually slow down. Eventually, the Earth will spin slowly enough that the same side of the Earth will always face the moon, just as the same side of the moon already always faces the Earth. This means that in the distant future, a day and a lunar month will each have the same length, about 50 of our current days. What's more, if the moon were to get too close to us, tidal forces from the Earth would be stronger than the gravity holding the moon together, so rocks on the moon's surface would literally start flying off into space, and the moon would disintegrate. This would also happen if the Earth were to get too close to the sun, and if you decided to fly into a black hole, it's what would actually do you in. Your spaceship would get ripped apart from tip to tail by tidal forces. Now that's bad tidings.
Bay of Fundy in Canada, between high tide and low tides, is pretty drastic. This little person came in, parked their boat, got out maybe for lunch, waited about 6 hours, and came back, and their boat was actually sitting on the bottom of the ocean. Hadn't sunk, the ocean went away. This is a very drastic example between high tide and low tide. If you've ever gone on a cruise ship, when you get to your destination, they tell you you need to be back on this cruise ship by, let's say, 5 o'clock. And if you're late, they will leave you. They will leave you in a foreign country, no questions asked, and say, bummer, we told you to be back by 5. The reason is that if they don't leave exactly when they're supposed to, those huge cruise ships cannot make it out of the bay because they have their schedule based around tides. They're big enough that these tides are going to affect whether or not they can leave. And if you're late and they had to wait an hour for you, that might cause the entire cruise ship to not be able to depart, and then everybody is behind schedule. If you hear the term tidal range, that just means what is the difference between high tide and low tide. Sometimes it might be 5 feet, sometimes it might be 15 feet. Is it during neap tide? Is it during spring tide? Is the sun at apogee or perigee, meaning farthest away or closest? So depending on the shape of the ocean floor, as well as the topography, depending on the location of the sun, the moon, and the earth in relation to one another, as well as where the moon is in its elliptical orbit, that's all going to change how high or how low tides are going to be. If we look at a time lapse and you wake up, let's say at 7 in the morning, and you take your dog out to go to the bathroom, your dog can actually walk, you and your dog can walk along this little area of the shore, and it's just fine. However, let's say you go to work, and at lunchtime, at 12 noon, you come back home in order to let your dog out. The tides come in. This area of the shore no longer is there. It is underwater. However, if you wait until 6 o'clock that evening, you have that area of the shore back, and you can take your dog out walking again. Now, one of my personal heroes discussing tides.
There's a lot of people out there who's going to have a problem with this because the news, when Sandy happened, Hurricane Sandy, they talked all about the tidal effects of the moon, and it was a full moon.
Yeah, okay.
And this is why Sandy was so...
Okay. There are only 2 things that affect the tides from the moon. You ready?
Go ahead.
The mass of the moon. Is that changing?
That never changes.
Okay. Is the mass of the moon higher at full moon than at half moon?
No, it's the same moon.
A. B. The distance to the moon. Okay?
Right.
The moon orbits us. Sometimes it's closer, sometimes it's farther away. That has nothing to do with the phase. It's an elliptical orbit. Sometimes it's closest to full moon, sometimes it's
not.
But it's not, okay?
Right.
Those are the only 2 things that affect the strength of the tides on Earth from the moon.
Okay.
So why do we have a higher tide during full moon? Because the sun's tides add to the full moon's tide. To the moon's tide.
So it's the sun.
It's the sun. Blame the sun.
Blame
Sandy on the sun, not the poor moon that dutifully orbits us every month of the year.
There's one more very interesting aspect of tides that we haven't talked about. Let's start this running. We're going to include the sun. And you can see as Earth orbits, the tide is pointed towards the moon. When it gets up perpendicular to the sun, that's a neap tide. It's not quite as high of a high tide or low of a low tide. We're going to click this last little box. And I want you to watch very closely what happens to that bulge of the water on Earth. I don't know if you guys saw it. Let me unclick it. As I click it, you can see that bulge actually, if I include the effects of Earth's rotation, that bulge actually changes where it's pointed. Right now, if I don't include the effects of Earth's rotation, it's pointed directly at the moon. If I include it, it points a little bit ahead of the moon. Let me explain what's happening. As the Earth is rotating, it's rotating through these bulges of water. Whenever anything moves through something, friction happens. The Earth rotating actually wants to pull this water forward. As it is pulling this water forward through friction, this bulge is going to be pulled forward a little bit in front of the moon. That's going to cause 2 things to happen. This bulge being in front of the moon is going to cause 2 things to happen. The friction between the Earth and the water, if you know anything about friction, it slows things down. Which means because this bulge is in front of the moon and there's friction between the water and the Earth, Earth's rotation is slowing down. The day is getting longer by like a millisecond a year. It's not noticeable to us. Over the course of billions of years that Earth has been around, the day has gotten a lot longer. Earth's rotation has slowed down a lot. The second effect that this is going to have, because this water is pointed in front of the moon, this water has gravity. And so just a little bit, this water is actually pulling the moon forward, almost as if there was a leash between this water and the moon, and that leash is trying to pull the moon forward. It's actually going to speed the moon up. And if it speeds the moon up, in order for the moon to stay in its orbit, it has to move farther away. So you may have heard that the moon is moving farther away from planet Earth. The reason that's happening is because of tides. Because this little bulge of water is pulling the moon forward and speeding it up, which means the moon is going to move farther away. So this little effect of tides is not only slowing down the rotation of Earth, making days longer, it's actually speeding up the orbit of the moon, causing it to move farther away. With those two things said, see if you can answer this question. And here's the answer. The moon is getting farther away. Gravity is weaker. Tides will be less strong. If the Earth is slowing down, it rotates into those bulges less often. Tides will become less frequent. And now it's time to answer your questions.